Hello students, welcome to this video. In this video we will solve question number 441 to 450 of permutations and combinations. Also the link to download the PDF will be in the description. At the end of video I will show you how you can download the books and maintain an updated copy. Also I will show you my question answer website where you can come and ask questions, because YouTube is not suited for mathematical questions. Formulas are not possible to be rendered in YouTube comment box, but on my web application you can render formulas, and that is a very convenient way to have question and answer. So without further ado, let's get started. Question 441 says that find the number of ways in which two Americans, two Britishers, one Chinese, one Dutch and one Egyptian can sit on a round table so that persons of the same nationality are separated. So we have 7 persons altogether. Number of ways of arranging them around the table is 6 factorial. We let the set A, that is, now we compute number of ways of arranging when two Americans are together, that is 5 factorial multiplied by 2 factorial, or 240. And number of Britishers when they are together is also 240. So from this two we have number of A union B is equal to Na plus Nb minus Na intersection B. So that is 384. Okay. Now we compute an A complement intersection B complement, that would be total minus A union B, that is 336, which is our required answer. So you need to understand how this Na map to the set of what the question asks. So why we have taken only A intersection B or A complement intersection B complement is the reason that the Americans and Britishers are the only two nationalities having multiple people. Other are single. So they cannot, there is no sense of them being together. Only Americans and Britishers can be together. Question 442 says that in how many ways can 5 cards be drawn from a complete deck of 52 cards so that all the suits are present? Now to understand this, you need to understand how cards are present. If you don't know how cards are present, you won't be able to understand that, the question. So learn about cards first. Let C denote the selection of cards in which clubs are absent. D denote the selection of cards in which diamonds are absent, H for hearts and S for spades. Then we have CDHS, that is number of selections would be 39C5. Now if you want to take intersection, that is 2 suits are absent, that would be 26C5. And intersection of 3 would be 13C5, because now 3 suits are absent. Each suit has 13 cards. And if intersection where all are absent, then obviously it would be 0. So now we take the union and apply the formula from the set theory. We have our answer as this much. Okay. Question 443 says that in how many ways can 6 distinguishable objects be distributed in 4 distinguishable boxes such that there is no empty box if exactly one box is empty? So we have 2 questions in here. So total number of distributions when there are no conditions is 4 to the power 6. Number of distributions when one box is empty is 4C1 into 3 to the power 6. Number of distributions when 2 boxes are empty is 4C2 2 to the power 6. The number of distributions when 3 boxes are empty is 4C3 1 to the power 6. Therefore, we have our required number of ways, total number of boxes minus 1 box being empty plus 2 boxes being empty minus 3 boxes being empty. That is 2260. And similarly, for exactly 1 box to be empty, we have the solution here, that is 2160. Question 444 says that find the number of ways to choose an ordered pair A, B of numbers from the set 1 through 10 such that mod of A minus B less than equal to 5. So total number of ways without any condition is 10 square is equal to 100. Let b minus a greater than 6, greater than equal to 6. Okay. We are given less than 6, we are taking the opposite condition, b minus a greater than equal to 6. So if a is greater than equal to 1, then b is less than equal to 10. Which implies that if a is 1 greater than 10, then b minus 5 less than equal to 5. And now this selection can be done in 5C2 ways, that is 10 ways. Similarly, a minus b greater than 6, this should be similarly. Anyway, so a minus b greater than, okay, it is b minus a. Now we write a minus b. So this will also give 10 ways. Thus required answer is 100 minus 10, that is 80. Question 445 says that suppose that in a poll made of 150 people, the following information was obtained. 70 of them read the Hindu, 80 read the Indian Express, and 50 read Deccan Herald. 30 read both the Hindu and the Indian Express, 20 read both the Hindu and the Deccan Herald, and 25 read both the Indian Express and Deccan Herald. Find at most how many of them read all the three. So this is basically a set theory question. It is not actually a permutation and combination question. So according to question intersection of all the people reading all three newspapers is less than 150. We have let H denote Hindu, I for Indian Express, and D for Deccan Herald. These are Indian newspapers. We are given that H is equal to 70, I is equal to 80, and D is equal to 50. That is number of elements in the set. Now the intersection is also given of two of them, 30, 20, and 25. So we compute this should be union, not intersection. This should be union actually. So we compute the union here, and in order to maximize this, we have to maximize union, that is 150. Also, there is something wrong here, okay? This is union, okay? This is not intersection. Total number of people given is 150, okay? So this should be union, and this should be union, and to maximize union, we have to maximize, sorry, this is fine. In order to maximize intersection, we have to maximize union. So this is union, and these two are fine, okay? So we put 150 here for the union, okay? And we substitute HID and these two, and we get this as 25. Question 446 says that Lewis Carroll, the famous author of Alice in Wonderland, Through the Looking Glass, The Hunting of the Sharp, and other wonderful works, was a mathematician whose real name was Charles Lutwidge Dawson. Here is a problem from his book, A Tangled Tale. Let S be the set of pensioners, E the set of those who lost an eye, and H those who lost an ear, A those who lost an arm, and L those who lost a leg. Given N of E is 70%, N of H is 75%, N of A is equal to 80%, N of L is equal to 85%. Find what percentage at least must have lost all the four. So let N of S be 100, okay? The set of pensioners. We let the number be 100. Now, pensioners number should be greater than equal to number of E union H. That is those who have lost an eye and those who have lost an ear, okay? So this union is equal to this much, okay? This implies that the intersection is greater than equal to 45. And similarly, we find N L intersection A, that is 65. And then we have NS is equal to 100 greater than equal to union of intersection of these two. So the intersection is greater than equal to 10. Therefore, there is at least 10% of people who must have lost all four. So this is actually again a set theory problem, not permutation combination problem. But set theory and permutation combination are quite close in relationship. Question 447 says that A, B, C, D, B integers greater than or equal to 0, D less than or equal to A, D less than or equal to B, and A plus B is equal to C plus D. Prove that there exist sets A and B satisfying n of A is equal to A, n of B is equal to B, and n of A union B is equal to C, and intersection is equal to D. So we are given that we know that A intersection B is subset of A. That means number of A intersection B is less than or equal to number of A. That is D less than or equal to A, and similarly D less than or equal to B. So this implies that A union B is equal to NA plus NB minus N A intersection B, that is C plus D is equal to A plus B. Question 448 says that how many positive integers of n digits exist such that each digit is 1, 2 or 3? How many of these contain all three of the digits 1, 2 and 3 at least once? So there is no restriction and repetition is allowed. Number of ways is 3 to the power n. There will be 3 to the power n such digits. Now number of n digit numbers, all of whose digits are 1 to 3 is 3 to the power n. The number of n digit numbers, numbers would be where all digits are 1 and 2 will be 2 to the power n minus 2. Thus total number of digits is 3 to the power n minus 3 into 2 to the power n minus 2. That is minus 3 also. So we have the final answer as 3 to the power n minus 3 into 2 to the power n plus 3. If you do not understand this question, let me know in the comment box. I will explain the answer a bit more. Question 449 says that A, B and C are the set of all the positive divisors of 10 to the power 60, 20 raised to the power 50 and 30 raised to the power 40 respectively. Find n of A union B union C. So 10 to the power 60 is equal to 2 raised to the power 16 multiplied by 5 raised to the power 60. Therefore, n of A is equal to 61 square into 20 to the power 50 is equal to 2 to the power 100 multiplied by 5 to the power 50. Therefore, n of B is equal to 101 in times 51, and there seems to be something wrong with this. The solution is a bit odd. Okay, let's see it. Okay, whatever be the number. Okay, so set of all positive divisors. All right. So let's say some value is there, x, y, z, whatever. I am not sure about this calculation anymore. This I'll have to actually compute it, and this is fairly odd. Okay, and this is again odd. So I'm not sure about the numbers. Let's say those are x, y, z. That is the number of divisors. So you compute intersection of A and B, and you compute intersection of B and C, and A and C. So you compute 3 intersections and then intersection of all 3. So whatever some number comes. So what we are looking, this is again should be union. Okay. So this is union. We get union as 73,001. So I will fix this. Okay, I'm not sure about these numbers. Actually, they may be correct. Okay, maybe there is no need to fix the numbers. I'll have to actually revisit this question. Right, so I will go ahead and read this question carefully after the video, and if there is any problem I will fix the solution. Basically these numbers I'll fix, and this union. The union is definitely wrong. Numbers may be correct. Question 450 says that find the number of integer solutions to the equation x1 plus x2 plus x3 is equal to 28, where x1 lies between 3 and 9, both inclusive, x2 lies between 0 and 8, and x3 lies between 7 and 17. So this is an interesting problem. First we assign 7 for x1, because that is the lower limit, 7 for x3. Now the problem remains of assigning remaining 18 among x1, x2 and x3 such that x1 has at most 6, x2 has at most 8, and x3 has almost 10. Thus number of ways of distributing 18 to these three sets is 20C2 or 190. Let D1 be the set of distributions where x1 gets at least 7, D2 gets D2 be the set of distributions where x2 gets at least 9, and D3 where x3 gets 11. So we compute D1 13C2, D2 11C2, and D3 9C2 36. Now we compute the intersections, and all the intersections we compute, and eventually we find the union to be 162. So the number of solutions is 190 minus 162 is equal to 28. So this one had a bit of permutation and combination. Most of the problems are from set theory. So you need to understand set theory. I will revisit this question 449. Okay, you also try to solve this 449 and let me know if correction is needed. Okay, so with this the video actually is done. Now I will show you how you can download the books. You can come to my website ashtavak.org and download algebra, trigonometry and coordinate geometry from second, third and fourth links. The PDF downloaded will not have date. So when you download, you add date to it, and why you need to add date is because if the PDF is updated, you need to know that the PDF has been updated, and the books have problems. Lots of typing mistakes are there, and I'm fixing them as we go through the videos. That's why it is important that you update the book. Also, more numbers, more problems when added, it will update the date. I cannot put the date in the file itself because then I will have to change all the links in YouTube videos every time I make a change, which is practically infeasible for me. Now for question answer website, you can come to my website ashtavak.org and you can make a login. For registration, all you need to do is pick a username and email. You will receive a confirmation email. Click the link, your email will be verified, then you log in, just give an email, you will be receiving a code, and put the code and you will be inside it. You can ask questions here. These are the tags which you can use to ask the questions. So right now tags are at one level, that is, for example, algebra is there, but subtopics are not there. I will slowly add the subtopics, but for now we can use algebra or trigonometry or coordinate geometry, calculus, geometry, etc. to ask the questions. There, this is also for programming, because I have programming playlist as well. So the website supports the math questions. So I'm writing a markdown help file, which when deployed will show you how we can make use of the website's editor. So thanks a lot for watching the video, and I hope that you are finding this video useful and informative. So once again, thanks a lot for watching the video, and we will meet tomorrow with 10 more problems on permutation combination. Thanks a lot for watching the video. Have a nice day, and we will meet tomorrow. Enjoy.